Ever find yourself staring at like an amethyst geode and you're just like, how? How does nature even make something so cool looking?
Yeah, they're pretty amazing.
Well, today we're going to like dig into that, right? We're diving deep into this new research all about these amethyst geodes, specifically in Uruguay.
Yeah, those Uruguayan ones are some of the biggest in the world, aren't they?
Yeah, huge. And it's not just about like, oh, pretty purple crystals, which, don't get me wrong, they're gorgeous. But this research actually like flips the script on how we thought they were formed.
It does, yeah. Especially inside those ancient lava flows in Uruguay. I mean, we're talking 134 million years old.
100. Okay, so that's a long time for those geological secrets to build up. I'm guessing scientists probably already had some theories about these geodes, though, right?
Oh, yeah, for sure. Like, for a long time, everyone just assumed the amethyst formed under super high temperatures, right? From fluids trapped inside the lava as it cooled.
Right. Volcanoes. Makes sense.
Exactly. It seemed pretty logical. But this new research, it kind of throws a wrench in that theory.
Okay, now you've got me curious. What these geological detectives find that has everyone so surprised?
So basically, they figured out that the amethyst actually formed at crazy low temperatures. We're talking maybe 15 to 60 degrees Celsius.
Hold up. That's basically room temperature, isn't it?
Pretty much. Not exactly the fiery volcanic cauldron everyone imagined.
That changes everything. So where does the amethyst come from then? If it's not from the molten heart of a volcano or whatever.
Well, that's where the story gets really interesting. This research looked at over 30 amethyst mines in Uruguay. They analyzed the geodes themselves, obviously, but also the rocks around them, even the water trapped inside.
Wait, there's water trapped inside these things, like little time capsules from millions of years ago.
Exactly. Those tiny water inclusions, that's what they're called. They're like little messages from the past. And get this, scientists have these incredible techniques now. One of them is called, get ready for it, nucleation-assisted microthermometry.
Micro what now? Don't worry, I've got my geology dictionary right here. But seriously, what's so special about this technique?
It's like, imagine being able to recreate the conditions where the amethyst formed. Well, that's basically what this does. They analyze the water in those tiny inclusions to figure out the exact temperature, the pressure, everything from millions of years ago. It's totally changed how we understand how minerals form. It's not just for amethyst. They can use this for all kinds of geological mysteries.
So using this, like, high-tech time machine, they discovered that the amethyst geodes were formed, what, lukewarm?
Basically.
That's wild.
And it gets even wilder, actually. Remember how I mentioned they analyzed the groundwater and the surrounding rock?
Yeah, keep going.
Well, here's the aha moment. The chemical makeup of the water inside those amethyst geodes. Almost a perfect match to the groundwater.
Wait, are you saying like regular groundwater? That's what helped make these incredible crystals.
That's exactly what it's looking like. Not some superheated volcanic fluid, just, good old-fashioned groundwater seeping through the volcanic rock over millions and millions of years, and that's what provided the perfect mix of stuff to make amethyst.
My mind is blown. That's like finding out the Mona Lisa was painted with mud, not fancy oil paints. Like, it totally changes how we think about what you need to make something so amazing.
Right. It makes you wonder what other geological wonders are just the result of these slow, quiet processes that nobody really thinks about.
The slow and steady groundwater wins the amethyst race. But this groundwater connection is really interesting, right? Because it's not some alien thing. I mean, we all know about groundwater, whether it's wells, springs, or just that it's down there.
Exactly. Easy to forget about what's happening out of sight. But this research, it's a good reminder that even the most incredible things can come from the most ordinary sources.
Speaking of incredible, this research could actually change the future of amethyst mining, especially in places like Uruguay, with those massive geodes.
Yeah, and you're right to bring those up, those massive geodes. It's one thing to talk about groundwater seeping through rock, but to think it can create something that big, those Uruguayan amethyst geodes, just wow. We're talking caves full of amethyst crystals taller than a person.
It's like Jules Verne territory. You almost expect to find like a lost city or something in there. But these discoveries about how the amethyst forms, especially on that scale, it's not just, a scientific curiosity. The article mentions something about amethyst mining too, right? Like real-world implications.
Oh, yeah, absolutely. See, right now, a lot of amethyst mining is, well, to put it nicely, it's not very precise.
Not exactly surgical.
Exactly. It's a lot of digging around and hoping for the best, which obviously that's not great for the environment. And it's not even that efficient.
So how does this new understanding of how amethyst actually forms How does that make things more sustainable?
Okay, so think of it like this. If we know the exact recipe for amethyst, right, the temperature, the water flow, the minerals, everything that has to come together, then geologists could theoretically make like a treasure map to find new deposits.
Instead of digging randomly, we can use science to find the best spots, like those geological surveys. But for amethyst.
You got it. This research could completely change how we explore for amethyst. Imagine using all these high-tech tools to find the amethyst before you even start digging.
That would be incredible. Less guessing, less environmental impact, and you might even end up with more amethyst. Everyone wins.
Exactly. It really shows how we can use scientific discoveries to do things better in the real world, working with nature, not against it, which is a good lesson for, well, everything, really.
Definitely. This whole deep dive has really got me thinking. I never really, put groundwater and amethyst together in my head.
It's not the most obvious connection.
It makes you wonder what other hidden gems, so to speak, are out there, just waiting for the right science to unlock them.
And don't forget about time. These processes to make something like those amethyst geodes. It reminds us that some of the most incredible things in the world, they take a long time. Like, way longer than we're used to thinking about.
It really puts things in perspective, doesn't it? Something as simple as, water seeping through rock over millions of years can make something as incredible as an amethyst geode.
It really does. It shows the power of patience, persistence, right? And just how amazing nature is. And for scientists, it reminds us to keep asking questions, to never just assume we know everything, and to always be ready for a surprise answer.
And that's the real aha moment here, right? It's not just about the amethyst. This research, it changes how we think about how the planet works, the forces that made it the way it is, all these hidden connections that we're only just starting to figure out. It's like we think we've got the Earth all figured out, and something like this comes along, just blows the whole thing wide open again.
Definitely feels like a brand new chapter in geology. And this one, it's all about low and slow, right? It really makes you rethink those huge dramatic formations, how they actually form.
And, speaking of dramatic formations, this doesn't just change how we see the past. This could be huge for the future, too, for amethyst mining specifically.
Oh, for sure. Imagine, instead of just finding new deposits, we could use this knowledge to actually help amethyst grow in a controlled way.
Wait, hold on. Are you saying, we could grow our own amethyst geodes using what we've learned from these ancient ones?
It's a real possibility. I mean, think about it. Material science, crystal growth, all that's advancing so fast. If we could recreate the exact conditions, just like those Uruguayan geodes had, the temperature, pressure, everything, we might be able to actually cultivate amethyst efficiently, sustainably.
That would be revolutionary. Amethyst could be way more available, and it wouldn't have to be so hard on the environment.
Exactly. And who knows what other geological mysteries we'll solve with this new understanding. If groundwater can create amethyst geodes like that, what else can it do over millions of years? What if other gems, other minerals are forming right now in the same way, just underground?
It's kind of mind-blowing when you think about it. We've discovered a whole new way of looking at geology. It's not all volcanoes and earthquakes. It's these subtle, slow processes that are just as important.
It's a good reminder that even in the quietest parts of the planet, amazing things are happening. We just have to pay attention, really observe, and never stop asking questions.
So to wrap things up, what's the biggest takeaway you hope our listeners get from all this, from diving into the world of amethyst and geological time?
That's a good question, I'd say. Never underestimate the power of those slow, steady forces. Sometimes the most amazing changes, they don't happen with a bang, but with a whisper. A slow drip, a gradual buildup over a long, long time.
I like that. Words to live by. And on that note, we'll leave everyone to ponder the mysteries of the Earth. Maybe go check out your local museum or rock shop and really take a good look at an amethyst geode. You never know. It might just spark your next big aha moment.